In the previous video, we looked at the mechanism of SN1 reaction, and we observed that the reaction involves a carbocation, and the formation of carbocation in the transition state becomes the rate determining step. And since tertiary carbocations are very stable, SN1 mechanism is just justifies why the rate is so high. So compared to what it would have been had the reaction followed SN2 mechanism. So what, let's look at the evidences. So let's look at the evidences that that are in agreement with the SN1 mechanism. The first evidence is that the alkyl halide, the alkyl halide is the only species is the only species that participates in the rate determining step, and this gives evidence that of the rate equation that we wrote. So rate depends only on the concentration of the alkyl halide. So that's what we observed in the free energy diagram also, that in the rate determining step, the rate determining step, only the formation of carbocation is involved. So that justifies the mechanism that only one species is involved in the rate determining step, which is the alkyl halide. Now let's look at the second evidence. Since the formation of tertiary carbocation is more favorable as it is stabilized by hyperconjugation, hyperconjugation it it gives evidence that why tertiary is more reactive than secondary, which is more reactive than primary. So this is the order in which carbocations react in the SN1 mechanism. And since tertiary carbocations are more stable than, are very stable. So tertiary carbocations are very stable. So tertiary carbocations are very stable compared to a secondary carbocation, which is more stable than a primary carbocation. While primary carbocation is not stable, and so the reactivity also increases in an SN1 mechanism. The third evidence in favor of SN1 mechanism is that the the product that is formed with both retention. I'll rewrite this. Both with retention as well as inversion of configuration. So when it is retention, that means the nucleophile attacks from the side from which the leaving group departs. And if it's inversion, the nucleophile attacks from the opposite side from opposite side to the side from where leaving group departs. And this is possible because carbocations are sp2 hybridized, and so you have attack happening either on this side or on this side. So because this is a sp2 hybridized carbon, and sp2 hybridized carbon, the carbon is it has a planar structure, so attack is possible on either side. That is, if so, attack is possible either from this side, or attack is possible. So if this is your nucleophile, so attack is possible either from this side or from the other side.